Hello, Algebra students. We're ready for Section 2 of Chapter 9. We're still working on solving quadratic equations, and we're going to keep talking about their graphs. Now, roots are another name for the solution to quadratic equations. Another name for roots are zeros. If you remember when we were factoring and we would have the quadratic equation equal to 0 and we'd solve for what made the equation 0, we said those are the roots. So when the y value is 0, that's where the parabola is going to cross the x-axis. Now if the solution is an integer, we call those integral roots. Integral roots are when you have integers as your answers. So there's a typo here in our notes. How many times it crosses the x-axis? This should say x, not y. How many times it crosses the x-axis is how many roots a quadratic equation is going to have. So as you can see on the first one, it hits the x-axis twice, so it has two unique roots. Here it touches, the vertex is actually on the x-axis, so it has one real solution, and here the parabola does not touch the x-axis at all, so there are no real solutions. Okay, we're going to be able to use our graphing calculators, but I don't want you to be too dependent on your calculator, so let's review some things that we know. The first thing we need to do to solve quadratics is to put them in standard form. So when I take care of putting number 1 in standard form, I see a perfect square. The square root of x squared and the square root of 1 is x plus 1, same sign, both positive, and that's how you would factor that. And so what's going to make x plus 1 equal 0? Well, obviously when x is negative 1. So I have one root. That means that a rough sketch of this parabola is at negative 1, it's going to touch once at negative 1. So you can use that to double check your calculator, and you already know an idea of what the graph's going to look like before you ever even punch it in your calculator. Number 2, let's put it in standard form. Bring our 16 over. Is that another perfect square? I believe it might be. So we've got x plus 4, same sign, both positive. 4x and 4x makes 8x. And what's going to make that equal 0? Of course, negative 4. So again, that equation, that quadratic equation, has one root. And when I come to number 3 and I try to factor multiples of 5 that'll add to give me 4, same sign, both positive. There's only 5 and 1 because it's a prime number and it's not factorable, so it's prime. So since I can't factor it, what's its roots? There are no real roots. So when you run across a prime problem, when I ask you about the roots, you have to tell me there's no roots. Now for these next example problems, there should be 2 roots. So let's see if we can, we could factor. It's already in standard form, so we know it's opposite signs, and the larger number is going to be negative. So we have opposite signs, multiples of 10 that'll subtract to give us 3, 5 and 2, and the larger number is negative, so 5 and 2 subtract to give us a negative 3. And so my roots here are negative 2 and positive 5. These are the roots. Now be careful, that is not an ordered pair. That's actually negative 2, 0, and 5, 0, where the graph should hit the x-axis. So if you want to use your graphing calculator to check, or also we could, let's take the time to graph it down below. So what is our axis of symmetry? Our axis of symmetry, x equals negative b over 2a. So that's 3 over 2. So when x is 3 over 2, let's find our vertex. and that's going to be y equals 3 over 2 squared minus 3 times 3 over 2 minus 10. I'm going to punch all that in my calculator, and y equals negative 12.25. And instead of saying 3/2, let's say 1.5. So our vertex is at 1.5 and negative 12.25. So there's your vertex. And we know it's positive, so it opens up. And let's find the y-intercept. Our y-intercept, where x is 0 and y is negative 10. Remember, it's going to be our c. So with this information, knowing my vertex, my axis of symmetry, and my y-intercept, don't forget that I also know where it's going to hit the the x-axis. I know my roots. I am ready to graph this parabola. So here's my vertex at 1.5, negative 12.25. Here's my y-intercept. Here are my two roots, and so it would just be nice, it would make for a neater parabola if I could figure out exactly what the reflection is across the axis of symmetry here. Remember, there's an axis here, and so if that's my vertex and I'm at 1.5 and the y-intercept is 1.5 over, if I go 1.5 over this way, I'm going to be on 3. So check and see. If you plug 3 back into our formula, that's 3 squared, which is 9, minus 3 times 3, which is 9. So they cancel out, minus 10. So if I plug in, if x equals 3, then y equals negative 10. So instead of guessing, I'm sure that that's going to be the reflexive side. So I have exactly on the left the same points that I have on the right. And there's a sketch of that parabola. I'm going to let you try number 2 on your... Remember that it should have 2 roots also. Alright, on the next page I realize you don't have any parabolas on your graphs, but if you want to copy my parabolas you can, or just take a minute to look at the ones I've sort of quickly drawn here. Could you find the solutions for each of these? So if you look at number 1, there's 2 roots, so the solution here is going to be, the roots are going to be negative 2 right there and 1. If you look at number 2, there's only 1 root, so its root is at negative 5. And if you look at number 3, there are no real roots. So you can also solve if you're given the graph of a quadratic. And we'll just omit number 4. And when there is no real root, you know it's prime. It's not factorable. There's no multiples of 3 that'll add to give us 2. When I punch it in my calculator, the rough sketch of that parabola is here. I found the vertex, but just looking at your calculator screen, you can see that it does not pass through the x-axis. So you know that there are no real roots. So if all we're asking you to do is solve, then you can just look and say there's no real roots. If I'm asking you to graph, then you need to find the vertex and find where it hits the y-axis and so on and so forth. So they didn't actually ask us to graph this. It says solve by graphing, so you could solve it on your calculator. Alright, but sometimes on the test I'm going to ask you to actually put the graph so that I know you could do that. Alright, all of our roots so far, if there have been roots, they've been integers. They've been integral roots. But if there's not an integral root, it cannot be found, then we have to estimate the roots to the nearest tenth. And that's where the trace button on your calculator is going to come in very handy. So let's go ahead and practice putting this in our calculator and using our trace button to find our roots. Alright, so my calculator is acting up. We'll practice this some more in class tomorrow. But the first root is between 0 and 1. And I'm going to estimate that at about 0.6. and I can show you that again tomorrow in class. The second root is between 3 and 4, and I'm going to estimate that at about 3.4. So look at yours and using your trace button and see if you come up with two roots. And since they're not integers, this is an estimate, so it's around 0.5 or 0.6, and again between 3 and 4, but a little bit closer to 3, I think, but maybe 3.5. So if you said 0.5 and 3.5, that would be a very good estimate also. So we will practice using our calculators in class tomorrow. Go ahead and try number 3 here on your own and see if we come up with the same answer. So we're going to check number 3, and there was another one I left for you to do on your own. Oh yeah, number 2 on the second page. So have a great day. I'll see you tomorrow.